How do you solve SAT geometry circles problems? Honestly, these are one of the most complex and weird geometry problem types that you're going to see on the SAT. And actually, it's so weird that I even made a video one time where I specifically just clowned on them. In case you don't know, I'm the one who makes the SAT Gamify, the Minecraft SAT channel. And I actually had this video out one time. It was like a comedy video where I showed different things that can happen on the SAT, and I used Minecraft to show them. So I was like, this is how test day feels like, and it was like a field of TNT. I was like, this is how studying for the SAT feels like. You're like in a bedrock room. It's like super boring. So it was kind of a fun video. I actually took it down because I just thought like it was so cringe that I just did not want the public to see it anymore. But one thing I had in this video was circle problems. And I specifically said in that video, this is what it feels like when you see a circle problem, and I showed like a bunch of creepers walking towards you. So that's basically how circle problems feel on the SAT. They feel like creepers walking towards you, about to blow you up and completely destroy you. So that's what you're trying to deal with this. But thankfully, they are a lot simpler than they may initially seem. In fact, there's just a couple key things you need to understand about circle problems, and once you understand this, they become actually fairly simple, I would say. What you're about to watch is a snippet of a call I recently did in Mission 1400 Plus, which is my premium SAT Skool community. You can watch it and see what I explained specifically on circle problems and all the different tips given in that. Let me know what you think of it in the comment section below. If you want to join Mission 1400 Plus yourself, you can also see a link to it in the description as well. All right, guys, hope you enjoyed this video, and I'll talk to you again in a second. Okay, now onto circles here. This is a bit more common, actually. And the key thing you need to know, if you have never seen a circle before, surprising, a circle is this. So we got a rounded shape. Okay, I'm not sure how I'm explaining this. I mean, yes, you know what a circle is. The formula for a circle is this. Now, if you're confused what is going on here, definitely, check, Desmos. I talk about this in Desmos course, Desmos videos, everything. But just for a quick overview, what is being said here is HK would be the center point of the circle. So if I'm writing this into Desmos, HK would be this middle point right there. And to prove to you that this actually is the case, I'll just go ahead and write a random circle. So let's say I want the center point to be at, let's use a grade number, 6, 7. X minus 6 squared plus Y minus 7 squared. And I can just choose whatever thing I want. Let's just say equals 5 squared. Okay, does it work? Does it work? 6, 7, yes, it would be the middle of the circle. So that's proof that this works. You can just put it in and you get that as the thing. Now, if you're curious what this is representing, this would just be the radius of the circle. The radius is the amount of distance, or it is the distance between the middle point and then the edge of the circle. So if I count how far that is, that would be the radius. If you look at this here, the radius of this circle must be 5. I guess if I want to confirm that as well, I could look at here. So yeah, 11, 7. And then if I do 11 minus 6, that ends up being 5. So yeah, confirmed as well. So that's how you can draw a circle. And I'll go into a problem in a second where you have to actually use this formula, but that's the basics of it. Now, what about when it gets actually hard? I want you to think for a second that you just bought like a pizza. And so pizza, it's great. Let me see if I can actually make this look more like a pizza. Say this is the crust. Yeah. Okay, actually, I'm just going to give up on that. Okay, so let's say this is a pizza. And let's say you're trying to share the pizza with multiple people. And pizzas, they have 8 slices for most pizzas, regular pizzas. And so let's say that you have a friend who just went ahead and took 2 slices. Pretty fair. 2 out of the 8 slices have been taken by this friend. So I guess that would just end up being this piece. Think to yourself for a second, what percentage of the pizza was taken by his friend? It's not some kind of genius thing. It's 25%. Your friend ate 25% of the pizza. If you're asking how much of the pizza was taken, that's 25%. If you're asking how much of the crust was taken, it's 25%. Everything is 25%. 2 out of 8 is 25%. Yeah, all that stuff. So let me ask you for a second, what if we asked you, how big is this, essentially the crust of the pizza? How big is this portion specifically of this 2/8 that the friend took? Well, the obvious way you could figure it out is how much is the total circle for the crust, and let me just take 25% of that. Likewise, if I'm trying to find exactly how much space of the pizza that was taken up, again, I could just find how much space is in the circle and 25% of that. So not going to be any genius thing. It's pretty simple. It's just, anything you would logically think of if you're eating pizza. But there's a couple of just random formulas you need to know. So for a circle, the area of it, meaning the total space being taken up by the circle, is this formula pi r squared. Pi, in case you did not know, in case you're not like really big into math, it's just this random number that was discovered a bunch of many, many years ago, because it makes circles work. That's really is why it was discovered. And the radius is what I already explained. So you don't need to know anything about pi. If you just write pi on the SAT and Desmos, yep, it gives you, so pi. And then r squared. So this would be equal to the area of the circle. And then if I want to find the crust, or let's just use the actual term, the circumference of the circle, I would do 2 pi r. That is equal to the circumference, crust, whatever. So back to my example before, let's say that the radius was equal to like 3. Now we have everything we need to actually find out how much of the actual pizza that friend took. Let's first use the area. So pi r squared. Pi, and then we know the radius would be 3, so 3 squared. So 28, that is the total amount of the pizza being taken. That is the total area of the pizza. And so if we're looking at 25% of that, I could just literally put in Desmos 25% of that, which would be 7 point, yeah, that stuff. I could also just say here, if I want to, 2/8 of that, which would just be, 7.06. Likewise, if I want to do the same thing with the circumference of it, or crust, again, you can just do 2 times pi times 3, which would be this, and then I can also do 25% of that, which would be that. So that is the amount of crust of the pizza that this friend has taken. Now, the one other important thing to know here is that oftentimes it won't be a literal pizza. Okay, you probably already knew that. But more than that, you also need to know that they're likely going to give you an angle measurement here instead. So they might tell you that your friend, rather than eating 2/8 of the pizza, they ate 135 degrees of the pizza. Okay, if you're talking about degrees when eating pizza, that's you're kind of cooked there. But for the sake of math, that could be what it gives you. So 135 degrees. Now, keep in mind, what this is saying is that the circle overall, if you count everything, the total amount of angles of the circle always is going to add up to 360 degrees. That's just something you can memorize. Keep in mind, 360 degrees is the total amount of degrees in a circle. So if your friend ate 135 degrees, the logical thing we can just say here is 135 divided by 360, and then multiply that by thing, which would be, let's say 2 pi times 3. So that is the amount of pizza. Okay, and if I want to do the area again, I could just do pi times 3 squared. These are just like random rules, might appear in the SAT. This is not related to the last part. First thing here is with tangents. So if anybody's ever told you, that's tangential to the conversation, okay, I don't think anybody actually says that anymore, but if somebody did tell you that, what they're basically saying here is that you're talking about one thing, and then your friend is talking about something close to it, but not exactly the same thing. Like, let's say we're talking about let's say we're talking about the economy. And we're saying, the economy is so bad right now. And then your friend starts talking about politics. Those kind of are related. Economy is equivalent, not equivalent, but they're related in many ways. Economy affects politics, politics affects the economy, but they're not the same thing. They're only kind of related. And so that's basically what a tangent is. What a tangent is a line that touches the circle at one place, but then literally never again. It doesn't have any other relation besides this one place with the circle. So like this line over here. The big thing you must know, the big thing you have to know about this, the one thing above everything else, is that tangent lines are always going to be perpendicular, meaning they make a 90-degree angle to the radius of the circle. So in this example here, I could, draw this, a right angle here. And that's going to be important because now what you could theoretically do is make a right triangle with this, or actually 2 right triangles, both on either side. And then you can actually use the Pythagorean theorem or other right triangle stuff to figure out stuff about this circle or the area and this stuff, and that's lengths and stuff. So keep that in mind. Tangent is always perpendicular to this. And also remember, it can only go through exactly one point. If you ever see something where it is a line that goes like this, that would be considered a chord, not a tangent, which I'm not going to be going over in this call, but you likely will not see that on the SAT, so it's probably okay. Now, another thing you should know is inscribed angles. What this is referring to is basically if you have a situation where you have an angle on the outside of that interior angle, you have to know that that inscribed angle is half of the interior one. And this is very unlikely to appear on the SAT as well. I really have never seen this on any actual SAT. I think I do have a problem that I can show in a second that involves this I found from Onico, but as far as the actual SAT, I've really not seen an actual problem involving this. So unfortunate, but I guess it's okay. Last thing, one more niche rule, just to finish our list of 3 niche rules, is this thing with a triangle within a circle. If you see something like this, specifically if you see something where you have a triangle and it has this hypotenuse, which is the entire diameter of the circle. Diameter is just the radius times 2, so the entire like length of it, then you know that this must be a right triangle. That's just a rule you can know. If it's like this, you know this must be a right triangle. So that's one last thing. Okay, finally some actual stuff here. So this circle has a radius of 8 units. So let me just go ahead and draw that. So, and then what's the area of the sector determined by a central angle measuring 135? Okay, 135, there we see it again. Amazing stuff here. So it says the area of it. So that's going to be the pi r squared thing. So we can do pi times 8, which would be the radius squared. And so this would be the total area of the circle. This is the amount of space the circle takes up. And so 135 degrees, all we would have to do there is 135 divided by 360, and then just go ahead and multiply that amount by this, which would be 75. And then I just have to convert each of these numbers into that. So I can just see like 18 pi. Okay, that's not enough. 24 pi. Yep, that's enough. So therefore 24 pi must be the answer. So not too complicated, just pizza logic again. Now, one like simpler Desmos related problem, say you get given this equation, which lies outside of the circle. So this is going to be very, very simple. Like all I have to do is just write this out and just see which of these points is not within it. So 49, and then outside the circle, you know, I can literally just like type like 4, -2. Okay, that's inside the circle. You can see within it. Then 10, -2. Okay, yep, sure, that's outside the circle. That would be right. These, I'm sure if I tried it out, they would also not be in. Okay, this is another Desmos problem. If you have the endpoints of a circle of those, which of the following could be the equation for it? Similar to the other thing, I can just go ahead and type each of those in. And now I can just check to see, do each of these circles have the same thing as that? So I could do that, and then plus that equals 64. And then if I type that in, plus 6, and then plus 5 as equal to 16. Okay, that's also not it. If I do -6 and then -5, okay, yes, we see here, yeah, that would perfectly match with the thing there. A couple of the problems I didn't have in the original recording. First, this one. In Circle P, the minor arc AB has measured 120. The length of this arc is 6 pi centimeters. What is the radius of Circle P? So a few different things we have to do here. First, let's just draw what we're given here. And so it says it has a minor arc, which just means an arc. Whenever it says minor arc, it just means regular arc, of 120 degrees. And then it says the length of this arc is also 6 pi centimeters. So we both have the degree measurement and also the length of it. And now we're trying to see here what would be the radius of the thing. So this is basically like the pizza example, but now we're just kind of working backwards, I guess you could say. So basically we know here that if you have 120 divided by 360, that is equal to 6 pi, and then we don't know what the full amount is. So it could be x1. So that's what's going on here, because this full circumference, that's what's being shown by the 360, and that'd be x. So x1 says here is 56.55, so I can do 56.55 there. That is the full circumference of the circle. Now remember as well that circumference is 2 times pi r. So what we literally could just say here is 2 pi r equals 56.55, and then we get r must be equal to 9. Looks like a whole number, so probably is correct. So yeah, 9 is what I'm getting there for the answer. And so yeah, 9 would be the answer. Same kind of thing, we just set up a formula here basically instead of the other stuff that we did before. This is one inscribed angle problem. So if you remember up here, I was showing you how if you have an inscribed angle, the angle on the side is half of the one in the middle. So that's what's being shown over down here. So it says here minor arc AB, it gives us 10 pi. You may not be able to see that, but it says 10 pi for the length of the arc. And it's asking what is the area of the circle. So we're gonna have to do some similar stuff for this one. We just have different information to work off of. So since it says 40 here, what we know is that basically this is the equivalent as if it said 80 degrees in the middle, because that's what's being said with the interior and exterior. So 40 and then 80 degrees. So what we really are seeing here is pretty much the exact same thing as the last problem. 80 divided by 360 tilde 10 pi divided by, I don't know, x1. So we know the full circumference of this is 141.37. So I can then do 141.37 again and do 2 times pi r. We now know the radius is that. And then with that, we can find the area of the circle, which is just be pi r squared, which we get is 1590. So yeah, 1590 should be the answer for this one as well. Just got to remember, if it's on the side, you use inscribed angle stuff. If it's in the middle, you use the regular stuff I already said in this video. Real quick, one with the tangent thing. So we have a circle here and it has the center of Q. And they have the points R and S that both lie on it. So like that. And then we have a random thing T over here. And then it's basically saying it's tangent to the circle. So it only passes through at one point for both of those, but it does intersect at T for sure. Okay, this line kind of looks bad. Okay, like that. And says the radius of the circle is 260 millimeters. So if we just do this, that would be equal to 260. And then it says the perimeter is 3880. So I'll just throw this over here because we don't know how it's going to play yet. But when it says the perimeter, that means the perimeter of this quadrilateral. So basically, if we were to draw a line, like to combine all this, if I do this side plus that side plus that side plus that side, it gives us 3880. And now we're trying to answer this one final question. What is the distance between points Q and T? So basically, if we write all the way down here to T, what would that be equal to? So let's use the information we have here and try to figure out some of this stuff. So we know that the radius must be 260. So another way we could theoretically write this is we could just make both of these be 260 because that's what it means. When they are showing this quadrilateral, each one of these is just the radius. And then we have 3880. What we can do is we can take 3880 and then subtract 260 and then subtract 260 again to just get rid of both those radii and then see what we have left. That'd be 3360. Okay, so what are you supposed to do with that? Well, the thing you should also know about this is when you have a situation like this, where you have basically a perfect, quadrilateral being made with a tangent line, this line RT and this line ST will be the exact same as each other. It just kind of makes sense. Like there's no other thing that would change about this. The radii both still must be the same. So therefore these lines must be the same as well. So you can just take the 3360 and since we know the rest of the perimeter must be evenly distributed among them, we can just divide it by 2. So 1680. So now we know that both of these lines would have to be 1680 as well. How can we use this for the problem? Well, what you may notice now is that since we know that there must be a right triangle between these two lines, we can basically just use the Pythagorean theorem. You may have not noticed this at first, but yeah, we have a right triangle here, 260, 1680, and then we have a hypotenuse basically that goes from Q to T, which is what we're solving for. So I can just go ahead and write it out there. So I can say 260 squared plus 1680 squared, and then tilde C squared, so 1700. So therefore the answer here would be 1700. It may look like I was doing a bunch of weird stuff here, but ultimately it was just a kind of a repeat of what we had before. We have a right triangle that's made with a tangent line. Only difference is that we have a quadrilateral, but we just know we separate the perimeter amongst the different sides of the quadrilateral, and then we can just use the Pythagorean theorem, which you should hopefully already know if you're watching this video. That is everything with circles on the SAT. I hope you enjoyed this video. Good luck on the SAT and make sure to always stay Gucci.